Section 3.3, solve systems of linear inequalities. Essential question, how can I solve systems of linear inequalities? Please write that down. Who uses this? Explorers can use systems of inequalities to determine the rates at which they must travel to avoid bad weather. So, what is a system of linear inequalities? We've dealt with a system of linear equalities. And so now, instead of equal signs, we're going to be using inequality signs. And what is it? A set of two or more linear inequalities with the same variables. The solution to a system of inequalities is often an infinite set of points that can be represented graphically by shading. When you graph multiple inequalities on the same graph, the region where the shadings overlap is the solution region. So in this lesson, it is very important that you know how to graph, and I didn't want to do that. I'm taking that away. A line. So if you need extra help with that, you need to let me know. So I'm not going to deal with these inequalities until we're all done graphing the line, but I am going to talk about a few things before I begin. Remember, whenever we deal with oops, it's not what I wanted. Whenever we deal with less than or greater than, recall, if you remember, that's an open circle. We dealt with a parenthesis, meaning it's not including the endpoints. Well, when we're dealing with lines, that means that this first line will be a dashed line, meaning the solution is everything greater than that line, not on it, not including it. Whereas this one is a solid line because when we have greater than or equal to, less than or equal to, that goes with, remember, a closed circle and a bracket. It includes, this means it includes all the values on the line. This one, it does not. So that's the key to remembering. So I'm going to write these, this is dashed. This means solid. So I'm going to show you that those all go together and those all go together. Another thing is you have to make sure your line is in slope-intercept form before you graph it, which is y equals mx plus b, which wasn't necessary when we were using substitution and elimination to solve a system of equations. Now let's just do a little comparison here. When we're solving systems of equations, remember, we would get one solution, no solution, or infinitely many. When we're dealing with inequalities, we're always going to get more than one solution. And if these two lines don't overlap at all, then there is no solution. We'll find out once we start graphing. All right, so I'm going to call this line right here is going to be my red line, and this one is going to be my green line. So let's start by graphing the red line. Well, we know how to graph a line. We start with the y-intercept, which is -3. 1, 2, 3. And now the slope is 1/2. So we go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Or starting back at the y-intercept, down 1 to the left 2, down 1 to the left 2, down 1 to left 2, down 1 to left 2. And now I'm going to draw, oh, no, it's a dashed line. So just doing a dashed. Oh, you know what? What I'm going to do though, if I have those dots, you're not going to notice my dashed line. So we probably should just kind of go like, well, that's fine. It's a dashed line. Hope that's clear that that is a dashed line. Now the solid line, the y-intercept is 2, and the slope is here. Oh, you may say, I don't see a number. Well, there's a negative sign. There's no number, which means it's 1. So the slope on this, it looks like I'm graphing it in blue. The slope is -1 over 1. Whereas up in this one, the slope was 1/2. Okay, so I'm going to go down 1 to the right one, down 1 to the right one, down 1 to the right one, down 1 to the right one. I'm going to keep going. Or up 1 to the left one, up 1 to the left one. Now, this is a solid line. So I'm going to grab that and see if I can do a nice solid line. There we go. There we go. Now, the one thing I like to check is the red line has a positive slope, so it better be going up and to the right, and it is. The blue line has a negative slope, so it better be going down and to the right. Always check those things before you start shading. Okay, now, what I'm going to do is I am going to grab my highlighter here, and I'm going to start with the red line. The red line is the dashed line. It says on the red line that your y values are less than that line. That means I'm going to shade below the line. My y value, remember, y is your up and your down. But if y is less than, y is smaller than this line. So that's going to be below. That's what I'm doing. Okay. Now we'll do the blue for this line. So for this line, it's greater than. Greater than means bigger. And again, remember your y's are your up and your down. So y values bigger than the line are going to be y values up here above the line. And watch what's going to happen. My color is all of a sudden going to change from blue to green. What that means is that is the solution. So I'm going to point that out here. Right in here. All that. The green is the solution. I'm going to just write a note here. All this is the solution, the green part. Now, if you're struggling with the shading above and below, you can always use a test point to check. And a nice, easy test point is this little point right here, which is 0, 0. And so what should happen is if I plug the point 0, 0 into the first inequality, I get 0 is less than 1/2 times 0 minus 3. Is 0 less than -3? No. And let's check it in the other one. 0 greater than or equal to 0 plus 2. Is 0 greater than or equal to 2? No. So therefore, I said no, which means that I definitely should not be shading over here. So that means that where I shaded is correct. You don't have to do this test point. That is not a requirement. Example 2. Graph the system of inequalities. Well, on example 1, they were both in slope-intercept form. They're not. And I can't graph without them being in slope-intercept form. So the first thing I'm going to do is hold on here. Get that back. There we go. All right. Okay. X minus 3y is less, oh, I lost my pen now. It's less than 6. All right, so that means I have to minus x. And honestly, what I'm going to do really quick here, and there's a reason why I'm doing this. I'm double checking if there's a reason why. Yes, there is a reason why I'm doing this. Okay, let me start over here. There we go. All right, I'm going to minus x on both sides. So I get negative 3y is less than negative x plus 6. Oh, I have to divide by a negative, and recall, when you divide by a negative and you're dealing with inequalities, the inequality has to flip. That's when you divide or multiply by a negative. Well, a negative x divided by a negative 3, that's just going to be a positive 1/3 x. 6 divided by a negative 3 is a negative 2. So there is my first inequality I'm going to graph. Second one, we have 2x plus y is greater than 1.5 minus 2x on both sides. Y is greater than negative 2x plus 1.5. All right. This will be a dashed line. This will also be a dashed line. There's a lot involved on these inequalities because number one, you have to know how to put an equation in slope-intercept form. So if you need help with that, you need to let me know. And number two, you need to know how to graph a line. I want to fix one thing just because that looks like a 15 and it's really not. It is a 1.5. Let's graph the blue line first. So the y-intercept is negative 2 and the slope is up 1/3. Or down 1 to the left 3. Down 1 to the left 3. So I'm going to write that here. So the slope is 1/3. The y-intercept is negative 2. And this line, the slope is negative 2. It's like negative 2/1. And the y-intercept is 1.5. All right. They're both dashed. And as you can see here, this line should be going, positive slope should be going up and to the right. This one better be going down and to the right. So let's do that. So we have 1.5. So we go up 1.5, which is right there. And now we're going to go down 2 to the right 1. 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 And up 2 to the left 1. Up 2 to the left 1. Up 2 to the left 1. And it's also a dashed line. There we go. Okay. So on the blue line here, y is greater than. That means I'm going to shade above the blue line. I want y values greater than the line. Y values greater than the line are above. Okay. And on the red line, which is this line right here, again, I want y values greater than. So I think I'm either above or below. Well, greater than, bigger is above. Y values are much bigger up here than down here. Down here, they're negative. Up here, they're positive. So the trouble is when you get a line that is almost vertical, students think of it as right and left. Nope. When we're shading and dealing with an equation in slope-intercept form, we're talking about up and down, above, below. So y greater than is above. So I'm shading above, and we're looking for the green, because remember, that's what our solution is. Now that looks like that's all green. Oh, then I changed, I'm shading above the red line. That's all the blue. So my solution, remember, is the green. What I say in class is I do have colored pencils in class that students can borrow and use because that does help quite a bit when we're doing all the shading. It's not a requirement, but I believe it does help. So now we could test. How about we do this? Let's pick a point. I'm seeing if I checked a point here. Let's check a test point here. Now, looking at that, it looks like 0, 0, again, should not be in the solution. So let's test 0, 0 for the fun of it. You don't have to do this. So if I plug it into the blue equation, I get y is that greater than 1/3 times 0 minus 2. Is 0 greater than negative 2? Yes. But let's try the other one. All right, let's change. Let's just do that. Let's go to the red one. Test 0, 0 again. Is 0 greater than negative 2 times 0 plus 1.5? Is 0 greater than 1.5? No. So notice what happened here. On the red line, or excuse me, not on the red line, on the blue line, which was over here, which probably what I should have done is kept all that blue so we know what line we're testing. We were testing the blue line. On the blue line, 0, 0 worked. That makes sense because that was in the yellow region. That's where we're shaded. But for the red line, 0, 0 did not work. Because remember, the solution is the green. 0, 0 is not in that solution. So if we use a test point and it works for one of the inequalities and not the other, it's not a solution. So we did shade correctly. That's our checking. But again, you don't have to do that. Some students feel it is helpful. The other thing you could do, if we know this is our solution, you could pick a point in that solution. So 1, 2, 3, up 2. Pick a point right there, 3, 2, and test it. If you plug 3, 2 in to the blue and to the red, it will make a true statement for both. Example 3, we're going to save for class. Example 4, we're going to save for class and pause the video and answer the questions.